Hello students, today discussion is about modern periodic table, group names and their reasons. So there are 18 groups are there in the modern periodic table and each and every group has its own name. So what are the reasons behind the names, what are the group names and what are the origins of all these names? Today we'll discuss in this video. So let us start the discussion. So students, group number 1. First group elements are called as alkali metals. So lithium, sodium, potassium, rubidium, cesium, francium comes under this group. And these elements, their valency is 1 and their valence electrons are 1. Group 1 elements also contain hydrogen. Group 1 starts with hydrogen, but hydrogen is not a metal. It is a non-metal, which is an exception. But it is placed in the metallic group, first group, because of its chemical resemblance. But hydrogen is not it doesn't comes under alkali metals, only from lithium to francium. These elements are called as alkali metals. These elements, this group is also called as lithium family. Why? Because it starts with lithium. The metal starts with lithium. So what is the meaning? What is the reason behind this alkali metals? Students, alkali, the word alkali means when a base dissolves in water, that is called as alkali. So all these elements which they can form basic oxides, for example lithium oxide, sodium oxide, potassium oxide, rubidium oxide, and when these oxides, they can easily dissolve in water and they form respective hydroxides which are strong bases. So like sodium hydroxide, which is a strong base, potassium hydroxide, the strong base. So the meaning of alkali, when a base dissolves in water, is called as alkali. So all these elements, they can form basic oxides, and these basic oxides can dissolve in water to form hydroxides. That's why these group elements are named as alkali metals. They belong to group 1 in the periodic table. Group number 2 elements are called as alkaline earth metals, and the elements are beryllium, magnesium, calcium, strontium, barium and radium. They belong to the group number 2 in the modern periodic table. And like we discussed, alkali refers to a base. When a base dissolves in water, called as alkali. Similarly, like first group element, these group elements can also dissolve in water and they form the respective hydroxides, except beryllium. Remaining all the metals like magnesium oxide dissolved in water, it produces magnesium hydroxide. Calcium oxide dissolves in water, forms calcium hydroxide. They also show basic character only. They almost group 1 elements, group 2 elements have similar chemical reactivity, except the fact that group 1 elements valency is 1, group 2 elements valency is 2. And why the term earth is added for the group 2 elements? So in the olden way of defining the thing, students, earth refers oxides of the metals. So these oxides which are basic in nature, so scientists used to call earth for these oxides in the olden terminology. So that's why earth was added to this group 2 elements, just to give the difference between, just to show the difference between group 1 elements and group 2 elements. So that, students, next, group 3 to 12, the whole D block elements has one name. The name is transition metals. So why these elements are called as transition metals? The whole 3 to 12, total 10 groups are there. So these elements are called as transition metals or transition elements. So let us check the name, the reason behind the naming. So students, if we can check the modern periodic table, in the extreme left side of the modern periodic table, there are extreme metals. Extreme metals means highly reactive metals. On the right side, there are extreme non-metals which are highly reactive. So students, in the periodic table, you can clearly change a shift of metallic nature to the non-metallic nature. That means a change is happening. A transition is happening. What's the meaning of transition, students? Transition means something is changing. So what is changing in the modern periodic table? The trend is changing. Trend means the elements are changing from metallic nature to the non-metallic nature. The elements are changing from electropositive character to the electronegative character. Of course, all the D block elements are metals only, but they are not highly reactive metals. So these are highly reactive metals, S block elements. Highly reactive non-metals are extreme P block elements. So they act like a bridge. That means this nature is going through these D block elements. So that's why these group elements clearly act like a transition from metallic nature to the non-metallic nature. That's why D block elements 3 to 12 are called as transition elements. But there is one exception here, students. You can check this part of the periodic table which is placed at the bottom of the periodic table. They are called as F block elements. They also belong to the group 3 to 12 only, 3 and 4. So these elements are not called as transition elements. They have their own name. These elements are called as inner transition elements. D block elements are called as transition elements, and these elements are called as inner transition elements. Why? Because students, if you want to place these elements, if you want to include these elements in the modern periodic table, you know how the periodic table looks like. I'll show you, just wait. So students, look at this periodic table. So this is how the periodic table looks like. So if you want to include these elements, the F block elements, in the main part of the periodic table, so where these elements are placed, students, they are placed inner to the D block elements. What the D block elements are called as transition elements. So if they are placed inner to the D block elements, these elements are called as inner transition elements, but they are not placed in this way. They are placed at the bottom of the periodic table. So why they are placed at the bottom of the periodic table? In another video, we'll discuss about this reason. Next, group number 13, students. Group number 13 elements are called as boron family, and the elements are boron, aluminium, gallium, indium, thallium, and nihonium. So these elements are called as boron family because the element starts with boron. That's it. They belong to the group 13 and their valence electrons are 3. The valency is 3. Sometimes these elements are also referred as trials. Why? Because they belong to the group 13. In the old notation of IUPAC, they belong to the group 3 and their valence electrons are 3, so called as trials. And also sometimes group 13 elements also referred as icosogens, which means mostly boron and the isotopes of boron exist in the nature like icosohedron shapes, but mainly, principally in the books also, in general, we refer group 13 elements as boron family. Why? Because it starts with boron. Group number 14. Students, group number 14 elements are called as carbon family, and the elements are carbon, silicon, germanium, tin, lead, and flerovium. So these elements belong to the group 14 in the periodic table. They comes under P block elements, and these elements starts with carbon, so called as carbon family. That's it. There is no other reason. Starts with carbon, so called as carbon family. These elements valence electrons are, these elements contains valence electrons 4 and their valence is 4. So that's why sometimes these elements can also referred as tetrails. Why? Because they contain valence electrons 4. And very rare cases, these elements also have different names, which in general we don't see these names in the books also. The names are, these group 14 elements are also called as crystallogens. Crystallogens means like whatever the crystals we can get from the nature, like all the gemstones, all the rubies, all these crystals are mostly principally made up of carbon and silicon and other impurities. So that's why these elements are also called as crystallogens. Why? Because majority of the crystals composition is coming from carbon and silicon. And there is one more name. The name is adamantogens. Adamant means it's like a strong rock with wide properties. So what is the rock with wide properties which is high in demand? Diamond. So what is diamond, students? What diamond is made up of? Diamond is made up of pure carbon. Allotrope of carbon is nothing but diamond. So based on the diamond, these group elements are also called as adamantogens. So students, next, group 15 elements. So group 15 elements are called as Pnictogens, like P silent and T silent, Pnictogens. So the elements are nitrogen, phosphorus, antimony, bismuth, and moscovium. So they belong to the group 15 in the periodic table from the P block elements, and their valence electrons are 5 and their valency is 3. So sometimes these elements are also called as pentyls. Why? Because they belong to the group 5 in the old notation of IUPAC group number, as well as they contain 5 valence electrons. So that's why these groups sometimes also referred as pentyls. First, let us discuss about why they are called as Pnictogens. So students, in Greek, Nico means to choke. To choke means unbreathable. So these group forms unbreathable gases. For example, nitrogen gas. So of course nitrogen gas is 78% in our atmosphere, but nitrogen gas, in the absence of oxygen, it is unbreathable. So based on this nitrogen gas, the group name, it got its name as Pnictogens. Nico means unbreathable gas. Students, next, group number 16. So group number 16 elements are called as Chalcogens, and the elements are like oxygen, sulfur, selenium, tellurium, and polonium. So they belong to the group 16 from the modern periodic table from the P block elements, and their valence electrons are 6 and their valency is 2. The general valency is 2. Sometimes these elements, this group of elements are also called as oxygen family. Why? Because the element starts with oxygen and generally called as chalcogens. Students, why they are called as chalcogens? Calc in Greek means copper. Gens means generators. So like these group elements generate copper. So that's why 16 group elements are called as chalcogens. So like how 16 group elements can generate copper? Copper is a D block element. It belongs to here. Like how these elements can generate copper? Do they generate by any nuclear reaction? The answer is no. Students, you already know copper is used from the ancient times. Like how copper is available in the nature? Like copper is available in the nature like the pure form, like gold? No. Copper available in the nature in its oxide form or in its sulfide form. Sometimes, very rarely, copper in the nature available in its selenium and tellurium forms also. Ultimately, if you want to refine copper, we can refine copper from oxygen and sulfur mainly. So while refining copper means extracting copper from oxygen and sulfur. So these group elements are producing copper not directly, not by any nuclear synthesis, by separation techniques, by decomposition process, by metallurgical process, we are getting copper from these group elements. So that's why these group elements are called as chalcogens. Students, next, group 17. Group 17 elements are called as halogens, and the elements are like fluorine, chlorine, bromine, iodine and astatine. So they belong to the group 17 in the modern periodic table from the P block. Their valence electrons are 7 and the valence is 1 in general. So these elements are called as halogen, students. The reason behind the name halo in Greek means sea salt. Gen means generator. With the meaning of the group name is, students, salt generators. Sea salt generators. Why? Because when these group elements, when they react with metals, they can produce a wide range of salts like sodium chloride, which is a common salt. Many students will confuse here. Salt is not a compound name, students. Salt is a family name. Sodium chloride is a common salt, NaCl. Chlorine belongs to the 17th group. Potassium chloride, chlorine belongs to the 17th group. Silver iodide, which is a salt. Silver is a metal. Iodine belongs to the halogens. Or potassium iodide, which is iodine belongs to the halogens. Like if you mention anything, when these group elements, when they react with metals, they produce salts. So that's why these group elements are called as halogens. And mostly these salts are present in the sea water, that's why the name halo means sea salt generators. Students, next, the last group in the modern periodic table, group 18. So group 18 elements are called as noble gases, and the elements are helium, neon, argon, krypton, xenon, radon. And the recently discovered and added element organism, which is in the 18th group. So they belong to the 18th group in the modern periodic table, which is coming from the P block element, but there is an exception. Helium is an S block element which is placed in the P block element in the 18th group because of its chemical resemblance. So what is the chemical nature of these elements? These group elements contains 8 electrons in their valence shell except helium. Helium contains only 2 electrons and their valency is 0. They do not react. These elements are unreactive element, and all the names of these groups coming from this behavior only, from this unreactivity only. So first, noble gases. The meaning of noble means like peace, calm. These are chemically inactive gases, students. That's why these elements are called as noble gases. And these group elements are also called as inert gases. The meaning of inertness is also the same. And their valency is 0. So that's why these elements are also called as zero group elements. And zero group is the old notation of IUPAC group number of this group. And these elements are also called as aerogens. Why? Because if you can check all these elements, helium, neon, argon, krypton, xenon, all these elements are gases. So all these gases form air. Aero means air. Gen means generator. So that's why these group elements are also called as aerogens. And one more thing, these elements are also called as inactive gases because of chemical inactivity. These are also called as rare gases because of less abundance. So these are all the family names of these 18th group elements. Now, if you find all these reasons helpful for you, please subscribe to my channel and follow the videos. Thank you, students.